go. Let's make sure to shut off the music and then switch over to here. For some reason, my Stream Deck stopped working. Good morning, party people. It wouldn't be a webcast without some kind of technical problem. Hopefully, we got that one technical problem out of the way, and now we're off to the races. Oh, let me mute the stream alerts because it looks like we're probably going to have people doing... how do I want to do that? Let me see. I may have to click around a little bit. Give me a second here. I'm going to click. There's that. Let's hide that. Actually, let's just delete it. I have a little alert that whenever people subscribe, it gives me a little ding, and I don't want y'all to have to deal with those dings all morning. They're still going. Hold on a second here. Let me fix that just to make sure. Let me delete a few of these here just to get them out of the way. It would drive me crazy, I know, if I was y'all and have to hear that all the time. Let's get rid of that, get rid of that, get rid of that, delete. That might do it. Let's get rid of this one over here too as well. And now let's come back over here and see if that did it. So good morning, party people. Oh my goodness, we have people from all over the world in here. Let's see, people are saying hi over in chat. We have India, Iceland, yay! Iceland, who is that? Arnie Freyr. I love the Icelandic accent. It's just like music to my ears. It's utterly unbelievable. We have Pakistan, Netherlands, Argentina, Arkansas. I was like, finally, we actually have someone from the United States in here. I always wonder how many people domestically actually show up for that. Seems like for some reason, whenever I do morning streams, it's really heavily populated with Europeans. Oh goodness, Kenya, Texas, Egypt, Philippines, Clearwater, Florida, Canada, Bulgaria, all over the place. So this is designed to be the very first internals class that you ever get about SQL Server. Like, how is it that the database engine is actually accomplishing your queries? Now, you don't need to know anything about database internals in order to make this work. All you really need to do is know how to write select queries. We're only going to be dealing with reads inside this class, reading data. We won't be dealing with inserts, updates, deletes. So right about the end of the class, we'll take a little bit of a look at how updates are affected. But mostly this is for people who need to get data in and out of SQL Server, Azure SQL DB, Amazon RDS, SQL Server, and want to understand better how Microsoft databases perform poorly as your data starts to grow. It's not the database's fault. We're just not doing the things that are necessary in order to help it out. Why performance gets worse as our data starts to grow. How in the Sam? Well, you know what? We'll just leave it. I guess we'll leave it on there. We'll get that nice little ding anytime anybody subscribes. Maybe I'll figure out how that actually works. Oh, I could do another thing. I could hit the mute button, and that'll probably do it. Maybe. Who knows? We'll find out as more people subscribe. We went up over 50,000 subscribers last month, and so we're actually running a contest next week. No, it actually starts tomorrow, I believe. Contest to thank y'all for working or for subscribing and liking the channel, getting us up over 50,000. And I'm going to give away a handful of free training class passes. Now, I'm going to pick them randomly out of the blog post comments to the most interesting YouTube channels that y'all go and find, which is kind of fun. All right, let's go ahead and get started. Let's switch over to here. Where's my fancy clicker? I move things all over the place this morning. I do not need that up on the window. So you can tell it's like the first live online class that I've given in a few weeks, because as I'm doing this, like, I'm finding all kinds of little things where I'm like, oh, I should fix this. Oh, I should fix that. So in this class, I am going to rely very heavily on a set of printed pages. You are going to see me constantly holding up a few pieces of paper that I actually print out and I use in order to illustrate SQL Server concepts. I want you to have these pieces of paper in hand. It's okay if you don't have a printer, if you're just going to tab over to them and just download the PDF. If you go to brentozar.com/go/engine right now, You don't have to register for anything. Right up at the top of the article, there's a, if you're watching this class live, go download these pages. Go grab that, because this PDF will make a world of difference in how you understand how the SQL Server engine works. See, everything that SQL Server does, it does in, not everything, but almost everything that it does in 8K pages, and you can think of them a lot like pieces of paper. I've taken the Stack Overflow database and I've arranged the data in the same kind of way that it's stored in the database engine, so that as we're executing queries, you're going to be looking at these pages and going, oh, now I understand why SQL Server has a hard time when this is in the where clause or when this is in the order by. So go grab right now from brentozar.com/go/engine. Go download the PDF. I'm going to give you a second to go do that so that you can go grab those pages. I just can't tell you enough how important this is. And while you do that, I'll have a sip of my tasty beverage. So funny, people are still putting in the places where they're from. That's totally okay. Now at this point, I won't go through and announce everyone. Chicago, Romania, Germany, Netherlands, Dallas. Am I going to Dallas? No, I'm going to Houston, I think, in a month or two. 2 months, I think. Okay, so now that you've downloaded that from brentozar.com/go/engine, where's the data come from? I built it using the Stack Overflow 2013 database. StackOverflow.com kindly provides their database in open source format in XML. You can then import that into SQL Server, and I've done that hard work for you. You don't have to go download this now, but I always have to credit them because of the way that it's licensed with open source. I have to credit them and say, here's where I got the data from, and you can go grab the data too as well. During today's class, if you'd like to replicate the screenshots, some of you will like to follow along with T-SQL as you go and see the execution plans. Just know that you're going to need SQL Server 2022 or newer, or Azure SQL DB or Amazon RDS SQL Server. You're going to want to set your cost threshold for parallelism reasonably high, and then you're also going to want to set your max degrees of parallelism higher than 1, just so that you can get parallel plans. So now let's get started with the actual class itself. If you open up the Stack Overflow database, one of the things that I like about it is that it's very intuitive. It's very self-explanatory. The comments table holds exactly what you think it holds. The users table holds exactly what you think it holds. The users table is a list of people who've ever posted a question, answered a question, left a comment over at Stack Overflow after they created an account. The way that the table is designed is it's got an ID column. Starts at 1 and goes up to a bajillion. That's an identity column. And that column happens to be the clustered index, also sometimes referred to as the primary key. Those two terms are a little bit different, but for today's class, we're going to say that it's the clustered primary key. You see the little key over there next to the ID. Whatever the key is, that dictates how the data is laid out on disk. If you take the very first page of your PDF handouts, the very first page, the white pages, this is the users table. I said that almost everything that SQL Server does, it does in 8K pages. Well, this is exactly how the users table looks like on disk. When SQL Server goes to write these pages to disk, you'll see that they're sorted by ID. 1, 2, 3, 4 goes up to a gajillion. So if you know somebody's user ID, you can dive directly into that part of the table and pull it out. If you're looking for other columns, it may be more challenging, like if you're looking for all the people whose display name is Brent, because the data isn't sorted by Brent. If you think about your data file, the size of the database when we have our Stack Overflow MDF file, it is just a bunch of 8K pages that are laid out on disk. Your database consists of nothing more than a bunch of these 8K pages. Each 8K page is dedicated just to one specific object. Like in this 8K page, all the data on here is the user's table. To be more specific, it's the clustered index of the user's table. These 8K pages are the smallest unit of data that SQL Server works with. SQL Server doesn't work with rows. SQL Server doesn't work with columns. SQL Server works with 8K pages. These 8K pages are exactly the same on disk as they are up in memory. So when you think about what your SQL Server's caching, that's also 8K pages that are up into memory. If we're going to read a row, for example, we're going to have to go find out which 8K page has that, then go access disk, go figure out how we're going to get that thing. And then after we've got that page up into memory, we can go through and work with it. If we're going to write a page, on the other hand, we're going to need to get that 8K page up into memory, make whatever changes we want to it, and then flush that 8K page back down to disk. In a perfect world, SQL Server glances at your query and says, oh, I know exactly how to execute this query. This query is easy to understand. I know exactly where the data that you want is. I know exactly which page it is. I know that it's up here in my cache. So I can jump to it up in memory, and then I can read it out to you as is. In that perfect world, SQL Server dives down into exactly one 8K page, reads your row out, it returns it to you, and then goes on about its busy day. I don't know about you, but that's not the world that I live in. I live in a world where SQL Server has to deal with all kinds of ugly queries. They're really complex and hard to understand. The queries go on for page after page. I have to take a shot of tequila whenever I want to understand someone's query. The data that I want is spread across many 8K pages, and SQL Server doesn't know which ones they are. SQL Server doesn't have that data up in cache, so it has to go read all that data up from storage. And then SQL Server has to do all kinds of work on the data, like grouping and sorting data together. In that world, our work looks very different. SQL Server has to constantly scan through all kinds of these 8K pages. In today's class, our goal is to get you to think the same way that SQL Server's engine has to think. Sometimes people will say, well, why doesn't SQL Server just magically do this or magically do that? But once you have these 8K pages in hand, it's a lot easier to understand the work that SQL Server has to do in order to accomplish all of this stuff. In today's class, you are going to be SQL Server, and I am going to be an end user sending you queries. I'm going to give you a query, and I want you to give me the execution plan in plain English. I don't want you saying things like, I'm going to build a B tree. I'm going to build a doubly linked list. No, you are a human being with a stack of these pieces of paper. This is the only copy of the data that you have. And how do you accomplish this query in plain English? For example, the first query that I'm going to give you is select ID from DBO users. There's no where clause. We're going to keep things extremely simple in the beginning. If you're going to execute this query, what does your execution plan look like in plain English? How do you accomplish this? Go. I'll give you a second. Oh, I have to turn on the audio again so that you can hear my countdown song while I have a sip of my tasty beverage. Doo-doo-doo. So IOS is a clustered index scan. Remember, let's keep things really simple. Tell me in plain English what you're going to do out of these stack of pieces of paper. If you were a human being, describe to me what you would do. What you're going to do is you're going to go grab the stack piece of paper. You're going to go grab the top piece of paper after the stack. Then, as you go through and read through this top stack of paper, you're going to read the ID of every single one of these rows. You're going to say them all out loud. A lot of you are nailing it over there in chat. So here's what SQL Server's execution plan looks like. Whether I get the estimated execution plan or the actual, and we'll talk about the differences of those as we go on through today's class. This is totally safe to get in SQL Server Management Studio or whatever tool you like to use. You can get execution plans by saying, show me the actual plan. SQL Server will report back what it did. We read the plans from right to left. It's not the only way you can read plans. There are other bloggers who will tell you how to read things the other way. But when you're just getting started reading execution plans, read right to left. Read in the direction that the arrows flow. And the top right operator is the first thing that the users did, or that the SQL Server did. So the top right operator, and I love these little icons. These little icons are really explanatory. They show you in a little diagram what's happening here. SQL Server starts at one end of the stack of pieces of paper and reads through until it's found the rows that it wants. So it scanned the clustered index, our only copy of the table. How much work was it to do this? In order to find out how much work a query does, one way to do it, it's not the only way, I'm going to show you another way through today's class, is to say set statistics IO on. This is a command that only affects your own session. It's totally safe to run in production. Everyone has permissions to do it. Doesn't make your query take any longer. Set statistics IO on will report back to you in the messages tab of SSMS of the number of logical reads that your query did. A logical read, I always kind of laugh. I mean, these terms are never going to change. Somebody at Microsoft set this in place, like 25 years ago. What they really should say in here is that this is measured in pages so that you understand what this unit of measure is. 7,405 pages. This is the smallest table in the Stack Overflow database. And yet, even though it's that tiny, that's still 15 reams of paper. Ream is such an oddball word, but ream of paper is that big thing that you get out of the copy machine at work when you want to steal some paper to take home to your own printer. It's 15 of the big things of paper. So as we're going through this, as we're going through query plans, I want you to think about having a supply closet over there that's got 15 reams worth of paper where you're going to have to go and get all this data out. And again, this is one of the smallest tables over at Stack Overflow. So next query. As I go through and change this query, I'm going to color code and bold the stuff that I'm changing. So let's add a filter. Show me all of the users where last access date is greater than 2014-07-01. How are you going to execute this query? Remember, the pieces of paper are exactly what you have in from your PDF, same thing that you have, and I also show it up here on the screen. How are you going to execute this query? Plain English. You got a little supply closet over in the corner of your room there. I know you've got all kinds of other things in the corner of your room. We don't want a webcam turned on in your office. We know what's going on over there. We see your posts on Reddit and your browser history. You're a dirty human being. So Paul Logan says, I'm going to go through all the stack of AK pages, and for everyone that has an ID or has a date greater than 7/01/2014, I'm going to say that row out loud. That is exactly correct. We are going to go through the entire stack of paper. Doesn't matter whether we start at the beginning or whether we start at the end. We're going to go through all of those, examining every last access date to see whether or not it meets our criteria. That's our execution plan in plain English. Let's take a look and see how SQL Server does it. And the plan looks a little bit different here. So it still says clustered index scan, because this is the only copy of the table that we have. We're going to read all of the pages in this table. If I look at the two versions of the query, up at the top I've got the one with no where clause, and the second I've got the one that has the where clause in it, saying only the ones from July of 2014 and forward. Look at their logical reads. They're identical. They both read, well, not identical. Identical is the wrong word, right? Maybe through beer goggles. But this one's actually a little bit higher whenever we've added the where clause. And right about now, you're like, hold on a second, Brent. Why is it that when I read less data, that when I want less data, why would I read more pages? Well, one of your first lessons out of here is that just because you have a where clause and your query outputs less data does not mean you read less data. And crazily enough, can actually mean that you end up reading more data. Because in the example of this query, if I go look at their two execution plans, the one with no where clause and then the one with a where clause, the one with no where clause went single-threaded. You don't see a parallelism operator. And the one with a where clause went parallel. Isn't that wild? One of the things that I love about SQL Server is it'll automatically parallelize a query when it thinks it makes sense. And SQL Server's work isn't necessarily to evenly balance the work across all the cores. SQL Server is just trying to make the query faster than it would be on one CPU core. One of the ways that it does it, in that first query, when we had no where clause, well, SQL Server could open up the very first page and go, all right, ID 1, ID 2, ID 3, ID 4. SQL Server could be yelling full speed out as soon as it starts reading. And for every page that it grabs, it's going to be yelling out IDs nonstop. It can completely saturate the network connection, yelling out IDs as fast as it can. But not with this query. Once we put in the where clause, not every row that we find is going to match. So SQL Server's smart enough to figure out, wait a second here, I could send multiple people into that supply closet. Each of them have furiously grabbing pieces of paper and examining that last access date, because it's going to take a little bit of time. It's going to take a little bit of CPU time in order to examine those last access dates. And then they're not going to be yelling out every row. They're only going to be yelling out some of them. 547, 1648. So we're not going to saturate a network card as easily, so it makes sense to divide and conquer this work across multiple CPU cores. SQL Server has to decide how to execute queries. It's got to decide all of this before your query even starts. It's got to evaluate what's going to be the most efficient way to execute a query. And part of the tools involved in doing this is that whenever SQL Server builds an execution plan like this, it calculates something called an estimated subtree cost. Estimated subtree cost. One on the left is the shows the estimated subtree cost for the query with no where clause, and then we have the query with the where clause. This estimated subtree cost is a rough measure of the CPU and I/O work required in order to perform a query. A long time ago, in a galaxy far, far away, back long before you were a twinkle in whose ever eye that was, somebody at Microsoft decided to calculate based on time. If a query took, say, 5 seconds to execute on one person's Dell Optiplex, then they would assign it an estimated subtree cost of 5. Those numbers are long gone. Today, estimated subtree cost has nothing to do with how long it'll actually take on your machine. So these days we use the term query bucks. We say the query costs an estimated 5 query bucks or 100 query bucks. Kendra Little coined this term. Coined the term. Get it? It's query bucks. She coined the term. Coined the term. So we had our artist go, we commissioned our artist to go draw a bunch of query bucks, and you can go download them, PDF them, or print them out. And there's a funny story about when I had a printing shop print out stacks of these, and they're double-sided, so they even look like real currency, which turns out to be a problem when you try to get that through customs. So the more complex that your query becomes, the more that your query is going to cost in terms of query bucks, meaning the query is going to be more complicated for CPU and the query is going to be more complicated for I/O. To illustrate that, let's make our query a little bit more complicated again. Let's order by last access date. I want you to find all the people who accessed the system since July the 1st of 2014, and then I want you to order them for me by last access date. Okay, buckle up. Let's talk for a second. Before you go typing your answer over in the YouTube chat, I want you to seriously think that you are a human being. I know it's hard for you to imagine because you think you are an all-knowing, omnipotent being who can somehow magically conjure things out of thin air. This is the data structure that you have. Don't go tell me, I'm going to build an index. No, you're not, because that's not how databases work. They don't build indexes for you on the fly. Database engines sit around and get pissed off because you have a lazy database administrator who isn't actually building any indexes. This is the data structure that you have. How are you going to execute this query? Go. Give you a second to... There we go. I used to try to use the Jeopardy theme, but then I found out that that was copyrighted. And I got in trouble for doing that, so we don't do that anymore. I'll sip up my tasty beverage while y'all figure that out. So yeah, it's getting a little bit harder now, right? Jason says, read all the data to find the matching records and sort the data. Right, how do you sort the data? That's where things get a little tricky. You're a human being. Okay, so we got a stack of people with answers coming through here on YouTube chat. I might the first one that looks kind of vaguely correct. Let's see if I read it. Juicy says, same as before, but now when I get through reading them, I'm going to need to write down the ID and date somewhere. Yes, Juicy, that is absolutely correct. Let's come over here to how we're going to do this in plain English. We're going to read through our stack of paper. And then as each time that we find a row that matches, we're going to write down somewhere the ID and last access date. So why do I have to write down both of those? I have to write down both of those because I need them sorted by last access date. And as I go through and read them, if I just try to write down the IDs and keep them in order, well, as soon as I've written down somebody's ID, I don't know what their last access date was. I'd have to go back to the list. So I'm going to have to write down their ID and last access date. And there are a couple of ways you could think about it. You could think about it as sorting while you go, or you could think about it as sorting afterwards. You could write all down the rows that match, and then you could go through and sort them afterwards. And I don't want you to get too hung up on the differences between those two. The point is that we have to do these two units of work. Another thing is, I flashed really quickly a notebook here, and I use small notebooks. I don't use notebooks this giant. But it's interesting to know that SQL Server actually uses the same 8K pages that it uses for tables. It also uses for things like sorts. It's going to go allocate a bunch of 8K pages in memory for your query. I always use a guy's voice for SQL Server because he's dumb and stubborn and he refuses to ask for directions. I'm being kind of sexist there. I'm allowed to. I'm a guy. So I use a guy's voice for SQL Server. So here's SQL Server's thought as he's building this execution plan. All right, well, I'm going to have to allocate a bunch of empty 8K pages in order to take notes. I'm going to have to think about how many rows are going to come back. And I'm going to allocate that much 8K pages so that then as I'm going through and I'm writing these down, I'm going to be able to sort them. Now that we know how it works in plain English, let's think about how it works in SQL Server. We're starting to get multiple operators inside our plan here. I think of each one of these operators as like a standalone microservice or an app on your phone that does very limited amounts of work. This thing can filter as it reads. For example, as it's reading through here, this clustered index scan can discard any rows that do not match what we're looking for. And then that little arrow there, you can think of it as a yelled list of IDs and last access dates. And then there's a separate sort operator over there. Each one of these little microservices does a relatively limited amount of work. So this thing's going to yell out like 100,000 IDs and last access dates. Then this thing over here is going to be scribbling those down and sorting them. It's two separate operations there. And then just for bonus fun, if you see all the way over there, the parallelism operator, this work is actually being broken up across multiple threads. So how does this compare to the last query that we ran? Over on the left-hand side is the query that had the where clause, and it shows that it cost around about 5 query bucks. Now we have a query with the sort, and our query cost is up by more than 2x. Our query cost more than doubled. And there's also a big growth here in this thing called memory grant. SQL Server needed space in order to write down all of our results that were coming through here. So SQL Server granted a bunch of 8K pages in order to do this work. You can see a little bit more about that if you right-click on the select operator and you go into properties. If you right-click on the select operator, go into properties, you'll see this memory grant info thing. These numbers are measured in kilobytes. So SQL Server has to grant this much memory in order to execute the query. One of the things that I find so extremely interesting about SQL Server is that SQL Server has to estimate all this before the query even starts. It's not usually revised during query execution. As your query is executing, whatever memory you got, that's what you're stuck with. SQL Server doesn't want you to all of a sudden blow up and get tons of memory, because that would stop other people from being able to run their queries the same time as you. And if you run out of memory, if you bring back more rows than you'd originally expected, you'll see a little yellow bang on your sort operator saying, "Danger, operator used tempdb to spill data during execution with spill level 1 and 3 spilled threads." And it'll actually tell you how many 8K pages SQL Server had to write to disk because it ran out of memory. I find this kind of funny because you could be the only query that's running at the time. And maybe the server has lots of RAM, but it would just be dangerous to give it all to you, because what happens while your terrible query is running when another query starts up? SQL Server has to let everybody cooperate. It can't keep them separated, so to speak. This is also one of the reasons that your query can work particularly well in a development environment and then fall apart in production. Because by default, any one running query can get up to 25% of your SQL Server's RAM. I'm going to say that again because it's really important and interesting. Any one query can get up to 25% of your SQL Server's RAM. It doesn't take a whole lot of 25% before you're all of a sudden screwed. And then you start to run into problems where queries can't even start because they can't get enough memory. Where someone was going in development, it worked just fine for me on my tiny little data set when no one is competing for memory. And then you go to deploy it in production and lots of queries are happening simultaneously and they can't get enough memory in order to start. All right, let's change something about the query. Let's change, instead of just getting the IDs, I want you to select star. Get star back. Now, how does that change your execution plan? I'll give you a moment to think about that. So how does our execution plan change? Aid says, and Robert says it does not. Are you sure about that? Are you sure about that? Are you sure about that? Because it's going to change at least one thing about it. What are we going to write down? And Andre nails it. That thing that we're going to write down is going to be much larger, which also means, as many of you are getting, Paul Arsalan says, we're going to need a much larger memory grant too. You'll hear database administrators say things like, Select Star sucks, but why does it suck? Does it mean that we need to read more data? This is a little bit tricky. We were already reading the whole table, right? William, I see you're joking. I love it. That's absolutely true. We were already reading the whole entire table, right? Actually, no. Look over at the far right-hand side of your table. See over at the far right-hand side of the table, there's this About Me column. The About Me is a big old nvarchar max. With an nvarchar max, you can store a relatively unlimited amount of data in there. I say relatively unlimited. It's on the terms of gigabytes, way more than a human being is going to type into an About Me profile. And that could be larger than what fits on one 8K page. So what SQL Server does is it stores pointers over to other 8K pages. If one of your users had, as Stephen King says, diarrhea of the word processor, and they wanted to write a big long letter to grandma inside their About Me column, well, SQL Server would have stored pointers in there over to other 8K pages, and we didn't need to read those before, but now we do. This is also one of the many reasons why you'll hear database administrators saying, don't put things like varchar max and nvarchar max in the data. Don't put JSON in the data. Don't put XML inside the data. You don't want to store large quantities of data inside the database if you don't have to. Right about now, developers get really pissed off. They're like, why do they call it a database? Well, XML and JSON are really files. They're not really data. It's not structured data in a way that you'd put into a relational database. So does this query end up working harder to read the data? Yes, because it ends up reading more 8K pages. We have to now follow the pointers and go grab this other data. Does it work harder to write the data? Oh, hell yes. Because now we got to write down much larger stacks of data. Now, some of you who are developers are thinking, hold on, wait a minute here. Why don't I just write down ID and last access date and sort those? And then on the way out the door, when I'm reading the results out, why don't I go from here back over to here and get all the other columns? I got the ID right here. I could just go look up the rest of the stuff on here. Yeah, no. That would mean holding locks on this while you work. And SQL Server needs to get you out the door as quickly as possible. So it's going to make you write all this stuff down rather than holding locks on this data. And then does it mean that we work select star? Does it mean that we work harder to output the data? And yes, this is the part that I always focused on as a database administrator. I was like, don't return the rows you don't, or the columns you don't need because it takes longer to save that thing over the network. In reality, that's the least of my problems. The biggest parts of my problem is the sort. That sort has now ballooned to 97% of the cost of this query, and the cost overall has exploded to a much higher cost. This query, before we added in the select star, this query used to cost like 13 query bucks, and now with our select star, it's up almost 900 query bucks. I'm not against select star. I'm fine with it when you're not doing joins and order bys. If all you need to do is render one user's page, if you need to display a user's profile, for example, sure, do select star. I understand that you put the data in there for a reason. Go select star for that one row, return the output, and call it a day. I don't care what you put inside there. That is fine with me. But when you start returning multiple rows and sorting them, and running that query more often. Let's do the exact same query again, and let's put go 100 down at the end. Go 100, or go whatever number you want, is a trick that works in Management Studio, where Management Studio will run the same query over and over again for you. It's like right before you leave for lunch, if you want to do a denial of service attack against the business intelligence machine, you can just go do things like this. And while you're at it, you should probably also go into Tools Options in Management Studio. There's a little checkbox for discard query results after execution. That way, if you check that box, then SQL Server Management Studio doesn't need a ton of memory to keep returning those display rows out. Did I say that out loud? I suppose that I did. So what's our execution plan for this query? What you would hope is that SQL Server would shuffle through all our 8K pages, reading out all of the IDs, last access dates, display names about me. It would go sort all those rows by last access date, and then keep it around. The results aren't that large compared to the size of our database, compared to the amount of work that we did over here. It would make sense for SQL Server to say, hang on a second, why don't we hang on to this for just a second in case the query comes again? People complain about SQL Server's costs. SQL Server Enterprise Edition is $7,000 a core. Oracle Enterprise Edition, $47,000 a core. That's one of the reasons that Larry Ellison was briefly last week, Larry Ellison founded Oracle, was briefly last week the wealthiest man in the world, took the spot away from Elon Musk. It's funny that I had to stop and think about the guy's name. Another reason that Oracle does all that cool stuff is that Larry Ellison also has a team of racing sailboats, and someone has to pay for all those racing sailboats, and that person is you. Microsoft, on the other hand, does not cache query results. This is a screenshot of this query in the midst of running 100 times over and over. SQL Server just burns up CPU and passes the savings on. Oh, there aren't any savings. SQL Server just burns more of your CPU, executing the same query over and over again. It doesn't matter if the data hasn't changed. It doesn't matter if no other queries have run. It doesn't matter if the entire database is marked as read-only. SQL Server caches this up in memory. SQL Server does not cache this. SQL Server does not cache query results, at least not yet. In SQL Server 2025, there are hidden settings. It hasn't come out yet. Has hidden settings that will appear to let you turn on query results caching, but they haven't shown us that yet. So the recap of what we've learned so far, Statistics.io shows you the number of 8K pages that have been read by your query. This is totally safe. This is safe to turn on for your stuff in production. You can get a good rough measure of how much work your query is doing. This is not the only measure. We'll talk about more measures as we go through this. Where, when you put your query as a where clause without an index to support it, that means you're most likely going to be doing a table scan. Doesn't mean that you're going to be reading less data. It means you're probably going to read just the same amount of data, whether you have a where clause or not. If I have an order by without an index to match, that means we're going to be doing a lot more CPU work. And because SQL Server is licensed by the CPU, that tends to get pretty expensive. And we learned that SQL Server caches raw data pages, but it does not cache query results or query workspace. In coming up next inside this class, what you're going to learn is how non-clustered indexes come into play, both in good news and bad news. And we're going to talk about the differences between seeks and scans. Some of you I get, because it's been a while, we've been going for about 45 minutes. Some of you are going to need to bail out at some point in order to go to your next meeting. If you do that, go to brentozar.com/go/engine. This entire class's recordings are available totally free. I do this class for free because I want people to understand how SQL Server's engine works, how Azure SQL DB works, and so forth. Then after this class, your next step would be my Fundamentals of Index Tuning class, where I talk to you about how you design indexes for queries, how SQL Server suggests indexes itself. I give you hands-on homework assignments to prove that you know what you think you know. And then after that, we jump into Fundamentals of Query Tuning. Now, I get that a lot of you don't have any money. Let's see how many people we got in the YouTube. We have 742 people watching right now. I get that 740 of you don't have any money. So I am going to teach the first half of each of these classes for free too. I haven't announced this publicly yet. Right now, as you're hearing this, this is the first time that this is being announced. On October 13th through 16th, I'm going to teach the first half of Fundamentals of Index Tuning, the first half of Fundamentals of Query Tuning, the first half of Fundamentals of Column Store, and the first half of Fundamentals of TempDB. It's going to be 9 a.m. to 1 p.m. Eastern Time. I know that a lot of you are from all over the world, and so, of course, you don't know what the timing looks like. So that way, you can go register for free, and there are calendar invites in there as well that you can go download, and it'll show you the exact times that it's going to be. This one is not going to be on YouTube. This one you have to actually register for. So you're going to go to brentozar.com/go/fun week, and then you're going to be able to register for this class, get reminders to it, get access to the calendar invites, and so on. I do this because I know exactly what it was like coming into database administration. That when I first got started, my boss didn't trust me enough to spend money on training classes. My boss was like, you need to exhaust all the free resources before you actually go into the paid stuff. And somehow my boss thought I was going to finish the entirety of YouTube, like I was going to walk back into his office sweaty and like 50 years later. All right, boss, I watched all of YouTube. I've run out. Now can you please give me some training budgets? So I like SQL Pilot says if it's for free, it's for me. So this I do totally for free for those of y'all who are just getting started. Now, if you can't attend this live, I am only doing it live for free for people who can clear out their schedule. If people can't attend live, you can buy the recordings. Every year I run a big Black Friday sale where I do deep discounts. If you want, I will give you the Black Friday discounts today only. This is not a hard sell. You can also get them in November. During all November long, I run my Black Friday sales, and this will be exactly this same price. So if you want to get access to the recordings, that's actually not true. I think the prices are $20 higher. I think it's $295 for during November. But you can get the recordings and get started on it now. This is today only. You can go grab at brentozar.com/go/early Black Friday. There are other sales on my mastering classes too as well during Black Friday, but this can at least get you. SQL Dev DBA says can confirm the real Black Friday class is $295. Sip of my tasty beverage. So for those of you who want the recordings, there you go. Now, let's go on with the show. Now, let's start digging into non-clustered indexes. So if we're going to run these queries over and over again, we need a way to make these queries fast. And the way that we're going to do that is to build a copy of the table pre-sorted in the order that we want. This is where the second page of your handouts comes in. Second page of your handouts is a black piece of paper. And the black piece of paper is the set of 8K pages that result if you run this command. Go create me an index on last access date and ID. Now, the first thing that you're going to notice is this is literally a copy of the table. We now have two separate copies of the same table. We have one copy that's the clustered index that's sorted by ID, and then we have another copy that's a non-clustered index. The difference between these two is that on a clustered index, you don't get to pick the columns that are included. Every column is on the clustered index, whether you want it or not. This is the entire table. The non-clustered index lets you pick which columns are on it. So I really think of non-clustered indexes as like a reporting copy of the table where you get to design what goes into this. And people get wild and crazy about indexes when they first get started with SQL Server, with Azure SQL DB. They create indexes left and right because they do dramatically improve the performance of queries. But the problem, one of the many problems now, is that now we have to do twice as many writes. Every time we're doing a delete, we have to delete both copies. We have to delete the copy on the index. We have to delete the copy on the non-clustered index. Every time we do an insert, we have to insert on both of these. And part of this work means that we got to get these 8K pages up into memory, change them, and then write them back down to disk. So the more indexes that you have, the slower your storage performs. The more indexes that you have, you are basically doing a denial of service attack against your own storage. I have been in performance tuning engagements where the answer was just simply dropping a bunch of indexes, and then all of a sudden the storage performed much better for the remaining indexes that we had. Now, I was really careful there to say deletes and inserts. I didn't say updates because updates only affect the copy of the table that have the column that we want. For example, what happens if someone changes their display name or changes their reputation or changes their age? What happens if we update Brent Ozar's age? I don't have to touch this index, because this index doesn't have age on it. In theory, you don't want to index hot columns, columns that change all the time, columns like reputation, for example, that we're constantly incrementing, columns like last access date. But we have that anyway, so here we are. The more frequently a column changes, the more we're going to have to write to our storage. In theory, I want to make people go to the clustered index if they want a hot column. If they want something like reputation, I'm going to say, okay, I'm going to index ID or display name. If you want to go look up someone by display name, but if you want to pull back their reputation, I ain't putting reputation on that index. I don't care how bad you want it because it's too hot of a column. As Tefanos says, how about clustering by a non-clustered index? You're kind of missing the point there because let's go back to the two indexes. If our clustered index is sorted by something, like let's say ID, would I want another copy sorted by ID? I'd be like, no, if you know the ID, go use this index. What if people said, well, we always look them up by display name. We want the entire table sorted by display name. Okay, cool. We can cluster on display name, but then you don't get a separate index on display name because if you know the display name and you're going over here for it, you only get one copy. It is fairly rare that you should have two indexes that start with the same column. In theory, less indexes are good. The less indexes you have is practical in order to support your workload. But of course, this is a balancing act, right? If you don't have any indexes, you're going to end up scanning the whole table every time the query runs. Every time any query runs, we're not going to have a copy that has what we're looking for. On the other hand, if I have too many indexes, then my deletes, updates, and inserts end up doing a denial of service attack across my storage. Plus, I end up with all kinds of blocking problems. And we cover more about that balancing point over in Fundamentals of Index Tuning. We talk about how to tell when you have too many indexes, how to tell when you don't have enough using real measurements. Well, let's go back to our select query. Now, go get me the IDs from the users where last access date is greater than July the 1st of 2014, order by last access date. Now that you have this copy of the table, what does your execution plan look like in plain English? Go ahead and type out over in YouTube chat to tell me how you're going to execute this query. Let's see what y'all get. Oh, I shouldn't even hum that because that's copyrighted. That might get me in trouble. Let's see here. Andrew just says it's much faster and more precise. Andrew, do you say that when your boss asks you, how are you going to accomplish this? Well, I'm going to be much faster and more precise. Yeah, but how are you going to do it? Give it fastly and precisely. No, when I ask for your plan, I want your plan. Show me how you're going to do it. So what you're probably going to do is you're going to go grab the non-clustered index on last access date. You're going to dive directly into the specific date that you're looking for, and then you're just going to read the IDs out in order. The data is already ordered by last access date, so you don't need to sort it. That's exactly how SQL Server works. Now, this new plan uses the index, and now we see a simpler query plan. Now we see an index seek. And again, I love the different execution plan icons inside here. You see how this icon looks a little different because now we're diving into one particular area of the index. We're diving into there and only reading out the rows that we need. And there's no sort anymore because the data is already sorted by last access date. Our estimated subtree cost has plummeted. It's gotten so cheap now. In terms of estimated query cost in query bucks, it's now less than one query buck. You can pay for it with query quarters. And even if you do select star, it's not even that bad because now SQL Server can dive just into those rows and they're already sorted in order. So why is it that the index is cheaper? And this is a little tricky because it's very easy to jump to conclusions and think that you know the answer, but bear with me for a second because you're going to learn something in here that's a little tricky. I'm going to run the same query 2 times. I'm going to first run it with an index hint on there. And hints, I hate the name index hint because it's not really a hint. It's kind of like how when your spouse or partner says to you, hey, I think the trash is starting to smell. That's a hint, but it's not really a hint, is it? It's a command. They're telling you to get up off your lazy rear end, put the controller down, stop playing Dead by Daylight. It's very hard for me. And then go down and take the trash out. It's not really a hint at all. Same thing with this. This is really a command. SQL Server, we're telling SQL Server, you have to use index ID number 1. And index ID number 1 is always the clustered index. So when we did index ID number 1, we read about 8,000 pages. When we let SQL Server choose now, it chooses the non-clustered index, and it reads less data. Okay, this is the part that you already knew about indexes. Indexes help us avoid reading so much data because we can seek directly into the part of the table that we want and just read those rows out. But that's not the only benefit. There's another benefit, and it's really big. To see the other benefit, I'm going to add another command up here at the top. I'm going to say set statistics and time, set statistics time and IO on. Time tells you how much time it took on the clock plus how much CPU time was used in order to execute the query. Here's the thing. It's not real accurate. And it's really unrepeatable. It can be all over the place. It can be all over the place depending on what other queries are running right now, what other machines are running on what other VMs are running on the same host that you're on, the power settings on the machine. There are all kinds of things that can affect how long the query takes like it's running. Because this query up here had to do the sorting, as Redshift says, this query up here had to do the sorting, and this query did not, our CPU time has dropped by a ton. This index right here perfectly covered everything that this query needed. This index allowed us to do less reads. It allowed us to do less CPU time. And this is why you'll hear people refer to an index like this as a covering index. But the term index or covering index doesn't mean a type of index that you go and create. And it's also not universal. It's only specific to this one query. As long as I'm running this exact query, then that exact index covers the query. But if I even change the query a little, it'll no longer be a covering index. One lesson that I want to make sure I don't teach is I don't want you to think that index seeks are fast. It's really easy to come under that impression when you see me doing index seeks inside this class and it seems like things are getting better. It's also easy to come up with that assumption because index seeks sound so lightweight. Seek, seek. It's like a little noise that a bird would make. Seek, seek. But that is not what it means at all. Just because it sounds small doesn't mean it is small. Seek into July the 1st of 2014. That's 10 years ago. That's a lot of data. You and I think as human beings that seek means I'm going to dive in and just read a couple few rows. That is not what it means at all. For example, to prove it, I'm going to change that date to January the 1st of 1800. Some of you are young, some of you are new here, some of you are attractive, not you, I'm talking to the other people. Some of you are attractive, some of you are young, you don't know, but Stack Overflow was not around in the days of covered wagons. Even though I have July the 1st of 1800, this still says seek. And it reads every single row in the table. You and I know that Stack Overflow wasn't around in the days of covered wagons. SQL Server does not. SQL Server doesn't know this. Yes, there are things about the database that SQL Server knows, but it's not a guarantee. SQL Server can't guarantee that somebody didn't just pump in a whole bunch of data for $17.99. To SQL Server, the term seek just means that we are going to jump to a row and begin reading there, but you could read the whole table, as our execution plan just did, and it'll still show a seek. To you and I as human beings, that is what we would consider a scan, but that is still what SQL Server considers a seek. Similarly, scan is not as bad as you think. Scan means that SQL Server is going to start at one end of the table, either the beginning or the end, and read until it has enough rows to satisfy what you're looking for. Here's an example of a scan that's amazing, and you cannot get a better execution plan for this query. There are no indexes that will make this query perform better. Go select top 10 star from users. SQL Server is going to go grab the very first page that it has and say, well, watch this, A, B, C, D, E, F, G. There we go. We're done. SQL Server is going to read just a couple of 8K pages to figure out where the table starts and then go start reading the pages. A seek can start at the first row and read the entire table. A scan can start at one end of the table and just read a few pages. I say this because I don't want you to come to the conclusion that I see people doing when they're tuning indexes or tuning queries and saying, oh, I looked at the plan and it's got nothing but index seeks. This is perfect. We're good here. The term seek doesn't mean good. The term scan doesn't mean bad. There are bad seeks. There are great scans. All right, so what have we learned so far? Indexes are literally a copy of the table. Now, the cool part is that non-clustered indexes let you pick which parts of the table that they are. You can only index certain columns if you want. You can even index only certain rows if you want. Indexes help you reduce page reads, and they help you reduce CPU for sorting. This latter part is more important in the day and age of the cloud, where we have to deal with things like costing by CPU. The bad parts of indexes is that they slow down how much deletes, updates, and inserts that we do. The more indexes that we have, the longer it's going to take us to do those deletes, updates, and inserts, and potentially the longer locking that we had. Seek on an execution plan just means we're going to jump to one part of the table and begin reading. It does not mean we're only going to read a few rows. You can have bad seeks just like you can have good scans, and that's completely okay. So what you're going to learn next inside the class is that you're going to learn key lookups, the concept of the tipping point. We're going to talk about how the engine chooses between different kinds of execution plans. We're going to talk about how SQL Server uses cost-based optimization to figure out the right query plan for you. And we'll talk about how statistics come into play. As a reminder, I have my totally free fundamentals weeks coming up. So I'm going to be teaching you much more. If you enjoy this class, you're going to be utterly blown away by the stuff in fundamentals of index tuning, fundamentals of query tuning, fundamentals of TempDB, and fundamentals of column store. I'm teaching the first half of each of those classes completely for free. And you can go sign up over at brentozar.com/go/funweek, where in the mornings Eastern time, really basically in the United States in the mornings for Monday, Tuesday, Wednesday, Thursday, we're going to be covering index tuning, query tuning, column store, and TempDB. And it's a great way to get started if your boss says you absolutely have no training budget whatsoever. These classes will require registration. You do have to actually go and sign up there, which means that you're going to be giving me your email address and your name. Why do I do that? Because I got to pay my bills too. And I figure even though right now you have a really crappy job and a crappy boss who does not appreciate your worth and what an incredible smart person you are, I believe that someday you are going to get a better job, especially if I invest in you and train you, teach you how to do a better job. It's going to help you equip yourself to interview questions better. You're going to be able to answer questions better, do a better job, have a better reputation amongst your peers, get better referrals. So you're going to get a better job. And then the next job that you get will actually be able to pay for training. You and I are in this together. I want you to make more money so that I can make more money. That's really... It's kind of maybe a little bit selfish, but here we are. All right, so next up. Now let's start thinking about how SQL Server is going to choose between execution plans. Let's go back to our query, getting just the ID where last access is greater than 7.1 of 2014. When we had this query, we said SQL Server is going to dive directly into one part of the table and read out the rows that it wants. And this index perfectly covers this query, gives us everything that we need to accomplish our job. Well, now let's change the query. Let's add a couple of columns to the query. Let's add a couple of columns to the query. Now, how do we execute that query? Andre says, will we be more attractive after those trainings? It depends on how much we both drink during those trainings. I may become more attractive during those trainings because you will drink with... I tell you what, there are so many times in my life that I've learned something about SQL Server and I had to take a shot at tequila because I was like, I made so many mistakes. I actually keep Class A tequila and a shot glass in my office. You would be surprised by how often I have to use this. Sometimes with clients, I will discover something extremely terrible, and I'll say, all right, most of you are working from home. We're going to take a minute now to take a shot of tequila to celebrate what we just learned, and learned the hard way usually, but suddenly the server performance goes better, and it has nothing to do with tequila. So how are we going to execute that query in plain English? This starts to become a little bit harder. We have this index, and then we have the clustered index. How do you want to accomplish this query? Let's see what y'all say. With the DDA, so it's seen SP Blitz and preferred qualifications and job descriptions. I know, it kind of amazed me when it started happening. I don't know, 10 years ago, somebody started sending me LinkedIn screenshots, and I was like, showing the jobs actually wanted my scripts, the scripts that I maintain. I like them all, but scripts that I maintain as part of the qualified job description. I was completely blown away by that. No one has answers here. That is hilarious. None of you have answers. Come on in there. Okay, so Joe says, go to the date index and write down the IDs and last access dates. We're going to go write them down over in our scratch pad. Then we'll go back to the clustered index, and Arsalan says the same thing. Fetch the additional columns that we don't have in order to get the additional columns that people had asked for. And that's certainly one way to do it. So one way we could do it is grab out of our index, go seek directly into the rows that we want, write down on our scratch pad the ID and last access dates, and then go grab the clustered index to get the extra display name and age. And sometimes that happens. So here's an example of where it happens. SQL Server starts with our index seek. Now we have actually like height-based execution plans as well. The first thing that SQL Server did, now you see why we read these plans right to left, also top to bottom. The first thing that SQL Server did was this index seek. Then, after it had found the IDs and last access dates that it wanted, then it went and did this key lookup over here on the clustered index in order to find the display name and age. Okay, now's the part where I have to tell you I lied to you. When I created this index, I created the index on last access date and ID, and I specifically told you that I created this index on last access date and ID. I didn't have to. I did that for easier storytelling. Bear, is it bear? Beard in color. I like how you did that there with the emoji. So SQL Server already puts the ID on there whether you asked for it or not. Because SQL Server has to be able to join between these two objects. For every row that it finds here, SQL Server has to be able to hop over to here. So it doesn't matter whether you put the ID in or not. As HC says, SQL Server is going to stash this in here secretly behind you. I could have just created the index on ID. There are actually going to be several lies that I told you that we're about to go shatter here as we move through this. But I say that I create the index on last access date and ID because it makes it easier to get started with the beginning of the class. Then I can hold this secret key column stuff for about an hour and 15 minutes in. Okay, so when I see that on an execution plan, when I see an index seek followed by a key lookup, this is a sign that you could tune your indexes in order to make them more efficient. What you could do is you could hover your mouse over the key lookup and you could look for the output list section. Output list tells you that this is what SQL Server had to go back that wasn't on the index. Dustin, the answer is yes to your question in chat, yes. So SQL Server will can, if you want, make the index wider in order to cover the query more perfectly. And this is a balancing act because the more columns that you add to your index, of course, if these are hot columns, they're going to be changed all the time, then we got to keep them up to date on every index, and that would suck pretty bad. Now, fortunately, age and display name They don't usually change that much, so it might make sense to add them. When adding them, we will also make the index physically larger because we're going to be able to store less rows on each AK page. Here comes the next lie, though. In order to go, see, you were absolutely right. SQL Server did an index seek plus a key lookup. This isn't my first rodeo. I know how human beings think when I ask you how you think SQL Server is going to build the query plan. I knew after decades of training that you were all going to say this first. That's not what SQL Server does. You thought it would be what SQL Server did, but the only reason the SQL Server did that was that I changed the year 2014 to the year 3014 so that SQL Server automatically knew this was not going to produce many rows. But let's go back to 2014. When I put 2014 in the query, SQL Server says, I'm not going to use your index. I am going to ignore your index, and instead, I am going to scan the entire table. Now, Mirka over in chat, who it would be really funny if Mirka's the same Mirka that I follow on Facebook and LinkedIn, and I'm not going to try to pronounce your last name. But Mirka says, for small data sets, SQL Server will do this other one. But I'll point out, this is a small data set. This is only 150,000 rows that we're dealing with. There's less than 300,000 rows in the entire table. This would fit on a thumb drive that would be so cheap. It is! Oh, Mirka. Oh, hi. Funny. That's funny. This is, to me, a really small data set. So what's happening here? SQL Server has this concept of something called a tipping point, where SQL Server says, if you're going to bring back roughly this many more rows, I think it's going to be more efficient in order to just scan the entire table and ignore your indexes. Redshift says it's about 20% of the size of the table. That is not true. It is an urban legend. I don't know where the hell that comes from, but I disprove it over at brentozar.com/go/tipping. It's not even close. If you wanted to use a rule of thumb, it's not even close. I've seen it happen as little as 1%, as little as 5%. I understand that on Redshift, don't feel bad. That means that you've read a lot on the internet. That's a good thing. That's a great thing. You've been educating yourself. You just chose the wrong places. And now, Redshift, you in particular, you need to go here. You found the smart guy. Billy says 20% of more of what you tip on meals. Billy, that's pretty good. I did not see that coming. I see a lot of jokes coming. I did not see that one coming, and I like it. So Redshift, brentozar.com/go/funweek. And I'm having fun with Redshift because Redshift is being a good commenter and putting in things inside of chat, which is fantastic. I like people like Redshift in my... I keep saying Redshift for short, and his name's their name is Redshift Galaxy, and I should say the full name because Redshift makes it sound like Amazon Redshift, and it probably doesn't have anything to do with what their name is, but back over here to the show. So why did SQL Server choose to scan the entire table? So to find out, what we're going to do is we're going to run two versions of the query. I'm going to run one without an index hint, and then I'm going to run one with an index hint. You'll see me do index hints inside my training classes. I do not recommend using index hints in production. The reason why I don't recommend index hints in production is because if anybody needs to change this index, if they rename it or if they drop it because a better index exists, your query flat out fails. That's not such a good idea. I'm not saying I've never used index hints. I just don't use them. I think I can count on one hand the number of times I've used them in my life in a production scenario. So I'm going to run one, let SQL Server decide. I'm going to run one with the index hint. When it's unhinted, SQL Server picks which indexes to use. It chose to do a table scan. When I hinted it, SQL Server did an index seek plus a key lookup. So SQL Server could absolutely do what y'all suggested. So why did it choose to do this version? When SQL Server is trying to decide which one to use, SQL Server looks at the estimated subtree cost. Estimated subtree cost is what the project manager thinks it will cost. So the project manager says, all right, well, that looks like it would cost about 12, 13 query bucks. Whereas if I look at the estimated subtree cost on the one with the index seek, that would cost 48 query bucks. So why would the one with an index seek plus a key lookup cost more? This one's doing a sort. This one is not. Well, there's something really tricky about this. The table scan is going to be a fixed amount of work no matter how many rows come back to read the data. It's going to be different based on sort cost, but doesn't matter how many rows match our filter, table scan, we're going to be able to read the whole thing once. If we do an index seek plus a key lookup, the more rows that we find here, the more lookups we have to do here. Man, sometimes I really hate SQL Server's execution plans. I really hate SQL Server's execution plans because you and I look at this and we're like, that's one key lookup. Nah, this is really three-dimensional. I wish these popped off the page based on the number of times that they were executed, because it wasn't one key lookup. We had to do it for every row that we found up here. If we brought back 150,000 rows, that's 150,000 key lookups that we have to do. And each key lookup is like 2, 3, 8K page reads. SQL Server has to go through that tree to find where the row lives. So this ends up being hundreds of thousands of page reads, whereas this is only about 8,000 page reads. Alan says I'm being quiet because I'm barely keeping up. And Alan, it's so funny. I have friends of mine, I have a good friend of mine who's a Microsoft certified master, who says that every time that they sit through this class, they learn something different. So don't feel bad about barely keeping up. This is also why I give this session all the time, and I put the recordings out there totally for free. You are not the only one. Friends of mine are like, wait a minute, I didn't really get how that exactly worked before. So SQL Server has to do all of this design before it reads a single 8K page. SQL Server has to figure out which execution plan it's going to use before it starts execution. Again, this is one of those cool things that Oracle can do. Oracle can change its execution plan mid-flight, trying to decide how it's going to access tables or bring back rows. SQL Server execution plans, they start, they're frozen solid exactly the way that they are. They don't get redesigned. Both Jeremy, Isaac and someone else also says the same thing. That they learn multiple things each time they go through. Isaac says it's his 5th or 6th time taking this and still learning new things. Dustin says, have you ever tried to put the details of this webcast in a primer of something of the sort before, Brent? So it's really funny. If you go down there to brentozar.com/go/engine, where it says the slides, the scripts, and database are at, there's a written version of this session too as well. Because I don't know about you. You know what people always really find funny? I hate watching videos. I do. I don't learn at all via videos. I almost never watch webcasts. Isn't that funny to say for a person who makes their living? I mean, I do a lot of things for a living, but one of the things that I do for a living is teaching you via video. And people learn in different ways. Some people prefer to learn via writing. Some people prefer to learn by putting their hands on a keyboard and doing demos themselves. So I try to make all of those different routes available through my training classes. So that way you can go hit the URL at the bottom of the slide and learn that way. I only say this, I don't say this to make fun of you. I say this to say that I'm with you, that I do the same thing, that I like reading via, or like writing, or reading. It's also something that I can do on airplanes too. So there you go. So how does SQL Server decide all of this before the query even starts? It has this thing called a cost-based optimizer. So what it's going to do is it's going to build an execution plan. It's going to come up with that estimated subtree cost, and then it's going to go build another version of the execution plan, and it's going to change and compare which plan costs the least. Now, I'm simplifying a lot here. I go into much more details of this both on the blog and in my fundamentals of query tuning classes. SQL Server has this whole cost-based optimizer that goes down all kinds of different branches. It doesn't go down every branch every time. It makes decisions on when it's going to use parallelism, when it's going to do missing index requests, when it does query reordering, and we talk about those over in the query tuning classes. The biggest tool that SQL Server uses in order to decide which plan it's going to use is statistics. For every index that we build, like in here, last access date ID, for every index that we build, SQL Server automatically builds a statistic on that same object with that same name. Plus, even if you're lazy and you don't create any indexes, SQL Server will automatically create statistics for you. A statistic is one 8K page of metadata describing the contents of that object. Yes, Andrew, I knew I was going to answer that, so I didn't mention it. A one 8K page worth of metadata describing the contents of the object. It doesn't matter how big your database is. It doesn't matter how big your table is. SQL Server just puts together one 8K page describing what's inside of that object. And that statistic helps SQL Server guess how many rows are going to come back from your query. For example, if you say where last access date is greater than July the 1st, SQL Server says, do I have a statistic on last access date? Let's go see how many rows I think it's going to match. You can see statistics. This is also totally safe to do. Here's a dbcc show statistics command. Now, I don't want you to think that I run this all the time. Honestly, the only time I ever run it is during training classes. Because once you know how this works, then you no longer have to run it. You just have to understand what the contents are going to be, and then all of a sudden you're going to understand how SQL Server builds this kind of thing. So DBO, I'm going to pass in dbcc show statistics. The first thing is a parameter. The second thing is, Carl, let's not ask unrelated questions here. Let's stay focused on the class. dbcc show statistics on DBO users IX last access date and ID. You pass in the name of the index or the system generated statistic, and you can actually see the contents of the statistic. The first thing, so you're seeing the contents of that 8K page. The first thing is a set of metadata describing the statistic. When was it last updated? How many rows were in there at the time of the update? How many rows did SQL Server sample? Second set is which columns the index or the statistic is describing. And then this set sounds like it's called a histogram, which sounds terrifyingly awkward, but it's really super simple. I suck at math. I suck at statistics. It's not some kind of humble joke. I seriously get out a calculator on the call with clients all the time. I'll bring it out on screen, and I'm like, I'm doing this calculation, and they're like, you don't know what 8 plus 4 is? And I'm like, look, if you paid me for my math skills, then we both made bad decisions. So this histogram is just a series of buckets that describe the contents of our data, describe how our data is laid out as best as SQL Server can do in one 8K page. Other data types get statistics too. In this example here, I've got one index on reputation. I've added an index on reputation just to show you what the histogram looks like on an integer. And then I've also done an index on display name so that you can see what a histogram looks like on name. Doesn't matter what data type you use, this dbcc show statistics works exactly the same way. When SQL Server needs to go figure out how many rows are going to match your query, what it does is it looks at the contents of your where clause, in this case, or other things inside your query or constraints. In this example, it's saying where last access date is greater than July the 1st. Well, okay, let's go pop open the statistics on last access date, and let's go scroll down until we find July the 1st of 2014. Now, there isn't a bucket for July the 1st of 2014. SQL Server has to do a little bit of work here. SQL Server has to guess which bucket it's in and then guess what percentage of that bucket is actually July the 1st. Then it goes down and adds up the rest of the buckets in order to figure out how many rows are going to match. This is where, when you're looking at a query, you see estimated number of rows. This is where that's coming from, is statistics. SQL Server guesses how many rows are going to come back, and in this case, holy smokes, SQL Server did an amazing job. Estimated number of rows and actual number of rows is really close. SQL Server was able to use really good statistics to figure out how many rows were going to match because the stats were up to date. We had an index on last access date. Our query was easy to understand. We weren't doing any fancy pants calculations on that. But as you look through that list, you can start to understand how this can go wrong, because if we don't have an index on last access date, if we don't have stats, if we have outdated stats on last access dates, if SQL Server had sampled the statistics on last access date. See, SQL Server is just like a political pollster. The larger that tables become, SQL Server can't afford to call every row and see, what's your idea? What's your data? Okay, what do you got? SQL Server will start to sample rows in smaller percentages. Another problem with it, as Pradeep says, the larger that your table becomes, like terabytes of data, that can mean that a single bucket might have millions or billions of rows in it, making it very hard for SQL Server to guess what percentage of the rows will match. I talked to you more about statistics and maintenance over at brentozar.com/go/stats class. And then also, our query may not be so easy to understand. Let's give you an example. I'm going to do the same query two ways. I'm going to say I want to find all the people who accessed the system in July of 2014. Oh, Riverside, let me tell you something. Riverside. The danger of giving answers, especially in my classes, is that when your answers are wrong, I will call you out. Riverside, you're off by 1. Who knows why? I bet somebody in here knows why. Riverside said that statistics will have 200 buckets in them, and that's not correct. Riverside, you're so close, you are off by 1. Why are you off by 1? Let's see if anybody knows. I do there. I said he's off by 1. Is the answer 199 or 201? And why? Mirka says 201. And why is 201 the right answer? Let's see who knows it. Ha! Koi selling snacks. Nathaniel says, are we zero inclusive? No, that's great. I like the joke, though. That's very funny, because I just recently had some kind of joke in, I think, the weekly newsletters about how I hate people who start counting as zero. William says 200 boundaries equals 199. Nope. Mirka says, I don't know why the answer is 201, but I should. The answer is 201. And the fact that no one knows it means that all of you should go to Fundamentals Week. It is so funny, especially all of y'all who are saying 199. Look, don't feel bad. I know a lot of you have been working with databases for 5, 10, 15 years, and you're blown away that in Brent Ozar's introductory class, the one that he gives away for free, you don't even know the answers in there. Your competitors, the other people who want the same jobs as you, watch these classes, and they know the answers. You ever wonder why it's so hard for you when you do job interviews and they start busting out the Trivial Pursuit questions? I sell a job interview class that tells interviewers what questions to ask you, and I give the answers in the class. Everyone around you knows this but you, but not the 700 people who are watching this class. Now, who nailed it? Pip. Pip37 says nulls. There is a separate bucket, very nicely. There are 201 buckets because one bucket is reserved for nulls. If your table has nulls in it and you update with full scans, you will see 201 buckets, not 200. Very nicely done, Pip. Everyone should give a nice round of applause for Pip37. Billy says, I feel personally attacked. I know, like, I always try to have fun in here and sweet talk y'all into learning and doing more things in here. Because if you don't hear from me, who are you going to hear from? The documentation isn't going to tell you how much you have or haven't read. Neil said, did you go to holiday yet? No, but the cruise is coming. It is either October 29th or 30th. So thank you all. Thank you all for helping me go on that cruise. Nathaniel says, does that include statistics on columns which are defined as not allowing null values? If there are no nulls, whether it's constrained or not, if there are no nulls, you won't see the null bucket. So on stuff that, whether it's constrained or not, if it doesn't have nulls and you do an update stats with full scan and the data is diverse enough, you'll see 200 buckets. But as soon as you have a null in there, whether it's, obviously you wouldn't have a null if it wasn't constrained. But if it's not constrained and someone puts in a null, then you'll have 201. All right, so back over here onto, Leppy says my yay button didn't work. Did I mute it already? Yeah. There we go. Got that. Thank you there, Yeppy. Yeppy? Leper. Leper 64. Okay, we'll come back over here. Let's see here. So we got these two ways of writing the query. Both of them are going to find all the people who accessed the system in July of 2014. Both of these queries produce the same number of rows. Both of them produce 728 rows, but you notice that their execution plan is different. Even though that you and I know that they're going to be producing exactly the same data, and they could be executed the same way, SQL Server could absolutely execute both of these the same way. SQL Server could do some math here and say, it turns out I should seek to July the 1st of 2014 and then end my seek in August the 1st of 2014. But SQL Server never built that logic in. Plus, this query was very easy to interpret. SQL Server could look at this at the time of building an execution plan, not do any thinking, and say, I think that about 700 rows is going to come back. But for this one that does more complex math, SQL Server's like, 1,800 rows? I'm going to guess 1,800 rows. The estimate is different. So we have a couple of things in here. One is that this one has an accurate estimated number of rows and uses the index. This one has an inaccurate estimate of the number of rows and it ignores the index. There's another difference between these two plans. The well-written query does not have a sort. The well-written query, because it uses the index and the data is already sorted by date, SQL Server doesn't need to do a sort. But on the poorly written query, SQL Server has to sort the data too. And of course, in order to see the overhead of the sort, we can turn on settings like statistics, I/O, and time. If I compare these two queries, the well-written query and the poorly written query, the well-written query that dives into the exact area of the index does less logical reads, uses less CPU time, and burns less time on the clock overall. The poorly written query is worse in every single way. When I'm doing index tuning, it's just a good reminder of when I'm looking at queries, I want to go through and make my queries as simple and easy to understand as possible so that SQL Server is more likely to use the right index. Now, SQL Server could use the index for this query. There's no reason it mechanically couldn't. And in order to prove it, we're going to take this query down here and we're going to copy paste two versions. I'm copy pasting two versions here. This is our original query where I let SQL Server pick. It's the poorly written query, but I let SQL Server pick which copy of the table to use. This, I am giving it an index hint. I am telling it, yo dog, I want you to use the index, and it can. Here's how it uses the index. When it does a clustered index scan, it still estimated the wrong number of rows. When I use the index, the estimate is still wrong, but SQL Server could absolutely scan this index, running the functions against it to check the year and month times. And in fact, the index does go faster. The index reads less data and consumes less CPU time. SQL Server could have used the index, but it did not. Why? It's mechanically possible. We said, some of y'all pointed out over in chat, oh, it's non-sargeable. Non-sargeable just means that SQL Server can't seek. It can't dive into one area of the index. That does not mean it couldn't use the index. It could, in fact, as we demonstrated when we forced it. So why didn't SQL Server use that index? The reason was that when we look at the estimated subtree cost, the table scan looks cheaper than the index seek plus key lookup. Table scan, SQL Server estimated 5.8 query bucks. The index seek, SQL Server estimated 6.1 query bucks. It estimated a higher number there. And that sounds odd when you and I know that the faster plan is the index seek plus key lookups. But SQL Server didn't know that because SQL Server used these bogus statistics because it couldn't understand how many rows were going to come back. The simpler your queries are, the easier it is for SQL Server to build good estimates. The more complex your queries are, they can run, but that doesn't mean they're going to get good estimates. So to recap what we've learned so far inside this class, a key lookup, when you see that on an execution plan, that means that SQL Server, your query wanted more columns than we had on the non-clustered index, so we had to jump back over to the clustered index in order to get the extra columns that weren't included here. SQL Server has to make a decision between the scan versus seek plus key lookup. In order, it has to do that, and it calculates a tipping point where it thinks SQL Server thinks it's more efficient to scan the entire table instead of doing all those key lookups. There is no one hard-coded tipping point, as we listed you to. What SQL Server does instead is cost out all these different plans, and as part of doing that, it uses statistics. So what you're going to learn next is you're going to learn how included columns start to mitigate the problems of bad queries, why included columns aren't as cool as they sound like on TV, how when you want to add columns as includes, and then why key column order is so important. As a reminder, because we're coming up on the second hour of the class, or coming up to start the third hour of the class, for those of you who have to leave, the recordings of this class are already out and freely available, both in written form, their demo form versions, video form versions. I teach it in lots of different ways. BrentOzar.com/go/engine, totally free. After this class, you're ready for my Fundamentals of Index Tuning class, where we start to teach how to design indexes without looking at an execution plan. So you can just glance at a query and immediately understand whether or not your indexes are going to make sense. If you don't have any money and you want to attend those classes for free, I am doing a totally free Fundamentals Week, October 13th through 16th, where I'm teaching fundamentals of index tuning, fundamentals of query tuning, fundamentals of column store, and fundamentals of TempDB. I'm teaching the first half of all of those classes completely for free at no charge. You can go register for it. These will not be on YouTube. These you'll actually have to register in order to attend. You can go hit that at BrentOzar.com/go/fun-week, all totally for free. Now, you do have to be live. Those will not be recorded and distributed for free. If you can't attend live, you can go grab the recordings now and start learning. those fundamentals recordings of the entire classes, plus my classes on Azure, Azure Data Networking, PowerShell, and much more, are all available early for my Black Friday sale today only at brentozar.com/go/early Black Friday. So if you want to jump in now and start your learning, you can go knock yourself out there. Dustin Wells says, Brent, what's the difference between this class and the How to Think Like the Engine Bigger Data Edition? Let's see. I wonder if, could it be as simple as that SQL Server performs differently when there's more data? No. Could it be that SQL Server makes different decisions as your data side? No. There's no way that it would be so obvious that it would be, it couldn't be. Could it be? Could it be that I am such a good instructor that I can put that in the title? No, probably not. I don't think so. Couldn't be. Who could ever know? All right, let's keep going. Now, let's start fixing problems by adding columns. When we last left off, we had these two versions of the same query, and I said with this great version of the query, SQL Server is able to understand how many rows are going to come back based on our statistics on this column. Here, though, SQL Server was not able to do a good job of how many rows were going to come back. So let's say that I can't fix the query, which happens to be surprisingly often as a consultant. People will say that I need you to make the server go faster. If I need to make the server go faster, Paul says you've dripped a bit of sarcasm on your t-shirt. I'm surprised I haven't gotten a comment about this t-shirt yet. This is one of my favorite bands. It's one of my favorite CDs, Concrete Blonde Bloodletting, back from the late 1990s, or early 1990s, I guess. Oh, Johnette Napolitano, just one of the most amazing voices in singing. And she's still alive. She lives on a ranch in Arizona, I believe, with her horses, has a really pretty Instagram. Doesn't post as often as I wish she would, but amazing woman. I say amazing. I don't really know that much about her. She could be a terrible person. All I know about her is from her songs, her band, and her Instagram. You know, her songs and her band are, abandoned as of long ago. But no. So just as a disclaimer, just in case. Mike says, are you going to go down by the river in New Orleans anytime soon? I have not since like 1 year after Katrina, 2 years after Katrina. Like 1 or 2 years after Katrina, I went and I was like, it's so pretty. New Orleans is all. I love Louisiana. We're going to go off topic for a second. I love Louisiana, but New Orleans is the only place in the world where I have ever wanted to carry a gun. I am not a gun owner. I fired a gun literally once in high school. A friend of mine had a shotgun and took me out hunting, and I fired a shotgun once. And I was like, yep, never need to do that again. No thanks. And right about now, people who are stalking me or want to break into my home are like, note to self, Brent does not own any firearms. This is true. New Orleans is the only place where I've ever wanted to carry a gun. And that got worse after Katrina. There's a lot of parts of New Orleans that are sketchy, which is rough. So when I go to Louisiana, I go to Lafayette, Louisiana. It's way smaller. It's not as pretty, but it has all the good food. All the good food. Blue Dog Cafe. Oh, my God. So I got these two versions of the queries right about now. People from New Orleans are like, never invite Brent to SQL Saturday. It's not true. I don't think they have a SQL Saturday in New Orleans. Do they have one in Baton Rouge? But I haven't been to that yet. So we have, Corey Taylor says that's where I am in Lafayette. I love Lafayette. It's absolutely fantastic. Great Préjeans, the Cajun food at Préjeans, the alligator balls. I mean, I could go on. I like etouffee, jambalaya, gumbo. Oh, so much good stuff there. So we got these two versions of the query. We got the great written version and the poorly written version. How can I make this poorly written version perform better without changing the query? One of the things that I said was when I'm looking at an execution plan, if I see a key lookup if I see a key lookup and I see an output list, that means that these are the things that SQL Server needed to go back to the clustered index for because they weren't on the non-clustered index. So what I can do is I can take those columns that we needed, the stuff that's in the output list, and go add them to the index itself. Now it's time to turn to the third page of your handouts. These are the gray pages. These gray pages are what comes up if you create an index on last access date, ID, display name, and age. Now the index has display name and age on it. So what does that mean for the index? Well, of course, one thing that it means is I now have literally 3 copies of the table. I have the clustered index, I got the index we created at first, now I got yet another index here. So now my inserts and deletes are going to have to do 3 times more writes. Another thing that's kind of tricky is this index, the gray index, is physically larger than this index. Oh, they both still are on 8K pages, but I can only have half as many rows on this page as I do on this page. Because on these gray pages, it takes space, it takes physical space to display name and age. I can fit less rows per page. The more columns that you add to your index, the less rows you can fit per page, which means the index is going to be larger. But the payoff is that now even the bad query will use it. Here, if I run our bad query, SQL Server says now, my estimates are still wrong. SQL Server doesn't understand how many rows they're going to have. My estimates are still wrong, but now because this index covers the query, because it has all of the columns that we want, SQL Server will use it and I don't have to force it into it. Pasquale says, do I need to indicate ID as well? No, we covered that earlier. We talked about earlier how SQL Server will put in the ID whether you want to or not. It's always included in an index regardless. So you can see the overhead of that index with our tool SP Blitz Index from our totally free first responder kit. SP Blitz Index, if you pass in a table name, will give you a list of the indexes that are on that table. CXPK means clustered index primary key. These are the white pages of the table. The entire table itself, in this case, I'm dealing with a larger version of Stack Overflow, has about 350 megabytes worth of space. Then the one that's in just on last access date and ID is about 43 megabytes. And as we tack in display name and age, it starts to approach closer to the size of the full table. The more indexes that you have and the more columns that they're on, the larger your database becomes. The larger your backups become, the longer your backups take. The longer table scans take, the longer your maintenance jobs take, the longer restores take, the longer CheckDB takes, the more updating statistics takes, the longer index rebuilds take. Everything maintenance-wise is going to take longer the more indexes that you have and the more columns that you have. You might have too many indexes if people are complaining about how long inserts and deletes take. Now, Jay Murphy, read the screen. It's on the screen, Jay Murphy. It's right there. If I could make it flash and say Jay Murphy, click here, I would, but I can't. You gotta meet me halfway. Read what's on the screen. Thank you. So you might have too many indexes if people are complaining about the speeds of inserts and deletes. Now, I'll be honest, not a lot of people complain about the speed. of inserts and deletes. It's relatively rare. In most cases, people are complaining about the speeds of selects, which is why Jay Murphy says, I will send more bacon. Which is why it usually makes sense to add indexes. But as people start to complain about the slow inserts and deletes, or if you're having problems with more monitoring tools warning about blocking and deadlocks, or if you're running into problems with your database maintenance windows, like you don't have enough time overnight, then you might have too many indexes. Most of the clients that I work with when it comes to consulting actually do have too many indexes, but it's only because people go wild and crazy with creating indexes in the beginning. They think that indexes are going to solve every performance problem. If people in your shop are complaining, or users are complaining about slow selects, and they're not complaining about inserts and deletes, and if you can already cache a good chunk of the database in memory, then those are signs that you probably want to start adding more indexes than if people are actively complaining about slow selects. One of the things that people do during index tuning is that they will use a lot of include columns. You'll hear people give advice out saying you can include these columns instead of putting them in the key. And they'll say includes are magically delicious. Includes are lighter ways to load data into your index, and they don't cost you as much. But is that true? Let's look at SP Blitz Index. I got these 2 copies of the index. I got one that's got everything in the key, and then I got another one that just includes these columns. Look at the sizes. They're about the same. Because their 8K data pages have the same stuff in them. Whether it's in the key or whether it's in the includes, doesn't really matter. In terms of these 8K data pages, the stuff is still there on the page. I don't want you thinking that includes are somehow more lightweight. Now people will say, well, hold on, though. It's different. These included columns, they're not sorted. When the data on the included columns gets changed, I don't have to move them around on the index. It's just totally lightweight. They're not sorted in any kind of order. Is that really going to help you at all? Let's think a little bit more deeply about how that works. Say that Sarcastic gets a year older. This is one page of that index. And this user Sarcastic gets 1 year older. We need to update Sarcastic's age. We're going to do an update to set Sarcastic's age to 31. This is where people who love includes will say, see, look, it's only included on the index. I don't have to move it. His age could change to 99, and we don't have to change it at all. It's just included. Okay, so how is that different if the age is in the index itself? Well, you're going to have to move him. Okay, use your finger. I know you've got bacon juice all over your finger this morning, but point at your monitor, not mine. Point at your monitor to when we change Sarcastic's age to 31. Point to where he's going to move to. Give you a second to take a look at the screen there. Sip of my tasty beverage. Where are we going to move Sarcastic's row to when we update his age? Right about now, you're realizing that he doesn't move at all. That's because the further that you get down in the keys, after the first couple of keys, the first 1 or 2 column keys are really important in an index. The first couple of column keys really determine where you lay out at. The ID sets the order in this case, or the last access date sets the order. In this case, as long as their last access date isn't changing, look how unique that is. Which makes sense, right? It's not like everybody logs in at the same time. All right, everyone, let's all get the same last access date. You ready? I got my password typed in. We're all going to hit enter at the same time, all right? 3, 2, 1, go. That's not how the internet works. Columns like last access date are very selective. They are very unique. And generally, whatever goes first and second in an index should be fairly unique. The first couple of two columns in an index are extremely important. But I don't really give a damn about the rest of the columns. I'm not saying includes are bad. I'm just saying they're not as cool as people think that they are. The big overhead doesn't really matter whether or not they're keys or includes. The big overhead is when that data changes, I have to get the page up into memory. I have to write on it to change the value. I had to lock the row while I'm doing my work, and then I have to flush it out back down to disk. That doesn't change whether it's in the key or the includes. It's the same exact work. It's the same exact work. The only thing people think they're saving is whether it's moving around, and it doesn't even move around if it's not in the first couple of columns. If your first couple of columns are all ties, you have a larger problem with your index. That index isn't very useful. It's like having a phone book that starts with alive or deceased. Well, I usually only look at the people who are alive. Then that's all you should put in the phone book. But don't put alive, 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 deceased, 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 deceased. That doesn't make any sense for indexing. The stuff that's at the beginning should be very selective, and you should only index the stuff that you care about. And the ways that you figure out how you do design on indexes is that you look at what things are in your where clause, what things are in your group by, your join and order. And we teach you how to do this stuff in my Fundamentals of Index Tuning class. I teach you how to figure out what make good index keys, especially leading keys, how to choose which ones should go first in the index. Then it's okay if you want to include things inside an index. I just don't want you to think that they're free. It's not free. It's just as much work in most cases than whether it was in the key or whether it was in the includes. So what have we learned in this last round of slides? The less columns that you have in an index, generally the less beneficial it is. We saw really quickly on when we were using just the index on last access date, it wasn't very useful because we ended up having to do lots of key lookups because people never want just one or two columns when they're getting the data back. However, the more columns that we add, the slower our database maintenance is going to go, our larger our database is going to become. So there's this balancing act that we have to walk to figure out how large of indexes we want and how small of indexes we want. So as a reminder, the next steps for you after this class are going to be that Fundamentals of Index Tuning class where we talk about how to design indexes for queries. We talk about how SQL Server designs indexes for you and why those designs are usually wrong. I give you hands-on assignments so you can test what you've learned during the class, and then I do the demos afterwards too so that you can compare your answers to mine and see how you did. And then the next step beyond that would be my Fundamentals of Query Tuning class. Now I know because you're broke people here on YouTube, you don't have unlimited funds, so I am teaching the first half of all of those classes for free, October 13th through 16th. These will not be on YouTube. You have to enroll in order to go to them, but you can go register for them over at brentozar.com/go/funweek. And I laugh because I really do think about my stuff. I try to make it as fun as possible because I know when I got started learning databases, I had really boring stuff like documentation and books where I could read for hours and not laugh once. I try to have a good time, and we have a good time in these classes. In the live classes, it's because I'm making fun of some of the comments out there. In the paid private classes, I end up making fun of SQL Server or myself most of the time. So you can go register for those over at brentozar.com/go/funweek. If you can't attend those live, you can also buy the recordings. The recordings are on sale today only. For today only, you can get the recordings of not just those classes, but also Azure Networking, PowerShell, running SQL Server in the cloud, fundamentals of parameter sniffing, and more. You can go buy those over at brentozar.com/go/early Black Friday. That is today only. It will also be tomorrow because I'm doing the first responder kit class tomorrow. So that is everything that I wanted to hit y'all with today. Why didn't it use that button? Hold on a second here. Let's switch over to there. There we go. That's better. So hopefully y'all had fun and learned something. I really enjoy this class. It's always a ton of fun to teach it. It also feels like it's so much fun tearing away the mystery of SQL Server so that once you've gone through this class, you go, oh, it's not such a crazy black box anymore. This stuff is fairly straightforward. Trevor says, I've been learning from your insights on LinkedIn. Really appreciate it. You're welcome. I post a lot of small stuff over there as well. It was funny. I used to use other social media. I've found LinkedIn has been much more active since the pandemic. It's been much more party time kind of thing. So thanks a lot for hanging out with me today. Hope y'all had fun and learned something. The recording of this will be out on YouTube, as well as, of course, if you go to brentozar.com/go/engine, there are other versions of this class. There's an all demo version where I do the whole thing inside of Management Studio, answering questions as I go. There's a bigger data version. There's a written version, all kinds of other stuff with screenshots. Don't forget, subscribe to the channel if you want to get notifications whenever I go live. Tomorrow, I have my How I Use the First Responder Kit class. I understand if you're too busy on both days and you can't make it. I also have another set coming next week where the next week ones are afternoon classes for different schedules. So thanks for hanging out with me, and I will see y'all next time. Adios.